Based on the variables considered by the model, the decision tree method works by making binary splits in a sample to maximize correct classification of those with and without the target of interest. All possible separations or cut points are tested, and the separation yielding the minimum impurity or error is selected, and subgroups showing similar outcomes but different explanatory variable constellations are generated. Decision tree methods also commonly employ a cross-validation procedure to guard against an overfit model, in which splits are included in the tree that do not actually improve the fit of the model. Following an initial growing of the tree, a random subset of the data is tested, that is, validation sample, and only branches of the tree that improve the correct classification rate are retained. Generally, the data is divided into training and validation or test subsamples, and the training sample is used to grow an overly large tree, while the validation or test sample is then used to estimate the rate at which the cases are misclassified. The misclassification rate is calculated for every sized tree, and the selected subtree represents the lowest probability of misclassification. In my example, the selected tree contains 11 nodes with 5 internal nodes in blue and 6 terminal nodes or leaves in green. Each internal node represents a decision point. For each node, the number of observations is presented along with the rate of adolescents who have or have not smoked regularly. The tree also includes the variables and cut points used to form the nodes. Notice that the binary marijuana use variable was the first variable to separate the sample into subgroups. Further subdivisions were made using a race variable, white versus non-white, the deviant behavior scale, whether the adolescent ever used alcohol, and their grade point average. Terminal nodes in green represent final subgroups. In this decision tree, there happens to be only one terminal node showing larger rates of adolescents who have smoked regularly, indicated in the striped pattern. There are 5 terminal nodes indicating subgroups with low rates of regular smoking behavior. As the tree diagram illustrates, white adolescents who have ever used marijuana and scored greater than or equal to 4.05 on the deviant behavior scale are more likely to have smoked regularly. The other 5 terminal nodes or leaves showed comparatively low rates of regular smoking behavior. Looking at the right side of the tree, these groups include 1. Adolescents who did not smoke marijuana or drink alcohol, and 2. Those adolescents who never smoked marijuana but have had alcohol. As you can see, within this subgroup, an additional binary split on grade point average shows that adolescents with a grade point average above 2.68, which is about a C+ or B- average, are at even lower risk for regular smoking than those with a grade point average below approximately a C+ or B-. The left side of the tree defines 2 additional subgroups at relatively low risk for regular smoking. The first is non-white adolescents who have smoked marijuana, and the second is white adolescents who have smoked marijuana and have a deviant behavior score less than 4.05. So as you can see, decision trees allow for a data-driven exploration of nonlinear relationships and interactions among many explanatory variables. These explanatory variables can be either quantitative, categorical, or both. Trees have the potential to fit numerous interactions that cannot be handled as efficiently in regression analyses, and they can also uncover constellations of variables that predict high and low rates of a given target or response variable.